Hey, okay, welcome to the show. Today we'll do part 2 of lab 2. So part A was pretty much done in the last video. We had some EtherChannel issue to deal with, right? Yeah, some sort of layer 2 issue to deal with. So we'll pull up lab 2. Again, it's another packet tracer lab. Come out of that, cancel that, cancel that. Alright. So we have this running topology, and there's some fault with it. So what we want to do is just apply all these configuration files to it. So let's pull up ALS1. Switch config. So stick, CLI, remove complete, paste. Okay. Let's start to make it quickly configure this one. Okay, let's just pull up the task. We know what we're doing. Alright, so topology 1 we did yesterday, and topology 2, here we go, trouble ticket 2. So it's saying again, there's been equipment failure. The technician was asked to configure the ether channels between ALS1 and the 2 distribution switches. But then shortly after those changes were made, users of ALS1, which is, well, in our case only PCB, so PCB is the only user of that switch. So users of ALS1 were unable to access the internet, which is simulated by loopback interface 0 on R2. So on R2 there's a loopback which simulates internet connectivity, and that's using the IP address 10.1.202.1, and we're asked to troubleshoot the problem. So the engineer has replaced this switch, and since the replacement of that switch there's been a problem with internet reachability, and he was specifically looking at bundled Ethernet links, which would be EtherChannel. So let's go on ALS1 and just take a quick look at the EtherChannel EtherChannel status. So show EtherChannel summary shows us on ALS1 we have 2 EtherChannels, port channel 1, port channel 2, and the member ports are fast Ethernet 01, fast Ethernet 02, fast Ethernet 03 and 4 for port channel 2. Alright, so each port channel has 2 interfaces, and both are in port channel mode and appear to be working. There's no heartbeat protocol, so there's no LACP or PAGP, so that seems fine. So while we're at it, let's take a look at DLS1. Show EtherChannel summary. So DLS1 has 2 port channels, port channel 10 and port channel 1, and port channel 1 is member interfaces 101 and 102. And looking at the, so let's have a look, 101 and 102 facing ALS1. So port channel 1 faces ALS1, which would make sense. So port channel 1 on ALS1 faces port channel 1 on DLS1. And let's go to DLS2. And on DLS2 there are also 2 port channels, port channel 10 and port channel 2. Port channel 10 member interfaces. Oh, didn't mean to do that. Port channel 10 interfaces 3 and 4. 3 and 4 go towards DLS1. So DLS1, this is the port channel 10. DLS1 to ALS1, this is port channel 1. DLS2 to ALS1, this is port channel 3. And all those port channels seem to be working just fine. So that seems fine. The configured bundled EtherChannel. Shortly after the changes, ALS1 users were unable to access the internet. Well, you know what? Let's jump to there. So we checked the EtherChannels. That was the first part of the ticket. Let's check reachability from PCB, which is here. Now you are given some information. PCB should be using DHCP, so let's have a look at the configuration of the desktop and the fast Ethernet 0. So the IP configuration is set at static at the moment. It should be DHCP, so let's make it DHCP. And let's see if we get a lease. Well, we don't get a lease. We do get an IP though, 169.254.138.146. And this is an auto IP. I'm not quite sure what the acronym is, but it's an auto-generated IP address, auto-provisioned IP address, or something like that. That devices pull when they're set to DHCP, but don't receive a lease. So there's something wrong with the DHCP request. So we can't really check layer 3 connectivity at this point because we don't have an IP address. What we could do to check reachability to the internet, though, is from a device that does have a layer 3 IP address in VLAN 10, and that would be DLS1. So let's go to DLS1. So in DLS1, let's do show IP interface brief. We'll see a list of all the interfaces. We can hopefully pipe that into up. So these are all the up interfaces. And VLAN 10's IP address is 10.110.252. And we're trying to ping the internet, which is represented by the loopback on R2, which is 10.1.202.1. So let's just do a quick show IP route for 10.1.202.1, and the subnet is not in the table. So we have no reachability to that network. Now that network is supposed to be on loopback interface 0 on R2, so looking at R2 on the diagram here, we've got R2 connected to R1, connected to DLS1, and R2 connected to R3, connected to DLS2. But visually we can see that this is red, and red is not good usually. So let's just have a quick look at that interface. Just check the physical diagram. So it says fast Ethernet 05 on DLS1. Fast Ethernet 05 on DLS1. So let's do show interface status. There are no fast Ethernet interfaces, they're all gig internet. So fast Ethernet 05 on the diagram is probably this one, gig 105. So its status at the moment is not connected. That makes sense if it's read on the physical topology. Let's show interfaces gig 105. We can see it's down, and we also see the line protocol is down, so that's a layer 2 or a physical layer fault. And it's negotiated half duplex, 100 megabits. Or has it negotiated? Has it been told to be? So it has negotiated. So A is auto. So it's negotiated auto 100 megs, and auto duplex has negotiated half duplex. Now usually this means that the remote is not configured for auto negotiation. So most likely the R1 interface is not configured for auto negotiation. Let's have a look over here. Show IP interface brief, same. So fast Ethernet 01, which is correct. So fast Ethernet 01 is up and protocol down, same thing. So show interface fast 01 shows the link is up but the line protocol is down, same thing. And we have a full duplex 100 megs per second negotiation, or otherwise. Let's have a quick look at the interface configuration of fast 01. So fast 01 has been physically set duplex full speed 100. And let's have a look at this one, gig 105. Oh, sugar. Alright, nope, okay, you don't like it. Fine, packet tracer, thanks. So gig 105 has been set duplex auto speed 100. So there's two ways we can fix this. One is to set duplex full on DLS1 or set duplex auto on R1, but both are fine. Either is fine, I would hope. So let's go into DLS1. It's usually better to hard code fast Ethernet in my experience, but we're in a simulated environment, who cares? Duplex. Ah, really? What's the problem? 105, 105, duplex auto. But there's no duplex command. Okay. Nice. Alright. So the only option available to us is to go into R1 and under Fast Ethernet 01 set duplex to auto. And then they will both match. So the speed is hard set to 100, but the duplex is now set to auto on both, so there's a match. So the port should come up, has come up on the physical diagram. Let's just do show IP. Interface brief on the switch. 105 is now up. You know, we've got two routers, so let's go R3 and check that configuration as well. Show run. Let's have a look at fast 01, fast 01, speed full. Alright, so let's have a look on DLS2, show run. 105 is set auto 100. So let's just check this one, see if this one's different to the other one. Do we have duplex? We do not have duplex, so I don't know how that command is even in the configuration. The default must be duplex auto. But if the default, no, actually it can't be, because usually the default commands don't show in the running config. Anyway, we need to do the same fix. So let's go into let's go into fast 01, and we'll do duplex auto. Okay, that's good. So let's come out and let's save that so that we have that. If we crash, we have it. Alright. Where were we? Okay, so on DLS1 now, let's take a look if we have that route in the table. Where was that? There we go. So show IP route 10.1.202.1. This is the internet route. The loopback of R2, and it is in there, and it's learned it via HSRP, and again via the the interface gig 105 towards 10.1.2.2, which should be the neighbor IP for R1. Should I do in brief 10.1.2.2? All right, so that's good. So between DLS1 and R1, we have this EtherChannel neighborship. Let's just check that. Show IP EtherChannel neighbor. And we see through gig 105, we have a neighborship there, and that is for R1. And so also on DLS2, there should be another neighborship, show IP HSRP neighbor to R3, which there is. So on R1, we should also have routes for VLAN 10, which we do, and 20 and 30 and so on. Sorry, on R2, show IP route, which we do. Okay, and the interesting thing here in R2, we have two routes of equal cost, one via 10.1.1.1, which is R1, and 10.1.1.5, which is R3. So R2 has load shared routing, 1 over serial 000, 1 over serial 001. Okay, where were we? So we need some layer 3 testing. Let's test from DLS1. Can we ping 10.1.202.1? We can. So we can ping this internet from DLS1, but the fault is because we replaced ALS1. ALS1, the users of ALS1 cannot access the internet. So let's take a look back now on ALS1 and try to see why. So we'll just do an interface, no, show interface, no, yeah. What do I want to do? Let's see what spanning tree we have here. No, in fact, let's just show VLANs brief. This is the list of VLANs on the switch itself. We have office, voice, guest. I'm just wondering what show interface. Show interface. Let's do a show interface status just to see what VLAN the PCB is connected to be sure. Is that it? That one there, 15. Yeah. So Fast Ethernet 18. Fast Ethernet 18 connected 10. So 10 VLAN 10. So VLAN 10 is PCB. So if we do show VLAN, nope, show spanning tree VLAN 10, just to check that it's forwarding VLAN 10, and it is. So forwarding VLAN 10 over fast Ethernet 018. That's towards PCB. That's good. We've also got VLAN 10 forwarding over port channel 2 and forwarding over port channel 1. That's good. So that should be fine. Let's just see. Show. So in the trunk we should have 10, 20, 30 port channel 1 and 2. Okay, fine. So it's forwarding the VLANs from ALS1. I'm not sure why the PC wouldn't receive. Let's just check VLAN 10. Let's do a reset on the DHCP. Let's see what happens. Okay, still not learning an IP. So VLAN 10 is forwarding ALS1 over port channel 1 and port channel 10. Sorry, port channel 2. So it's a DLS1 and 2, and DLS1 and 2 show spanning tree VLAN 10 on here is only forwarding over port channel 10. So okay, that makes sense. All right, so ALS1 seems to be fine, and DLS1 seems to have a problem, which is interesting because the fault says that we only replaced ALS1. So if we only replaced ALS1, why is that one for forwarding? Not to worry. So let's have a look. I think we already checked the ether channel. So the ether channel is up. Port channel 1 is up, but it's not trunking. It's not sending any VLANs over the trunk. Actually, we didn't check it was a trunk. Show interface trunk. Okay, yeah. So port channel 1 is not a trunk port. You can see port channel 10 is running 802.1q encapsulation, and it's trunking. And over on ALS1, we have the same situation. Port channel 1 is using 802.1q and it's trunking. So let's see why port channel 1 is not trunking here. So under port channel 1 configuration, we have a description, trunk native VLAN 900, and allowed VLANs are in a list. But what it's not doing is it's not negotiating the trunk with DTP. The port channel is configured there to use DTP to negotiate the trunk, whereas port channel 10 is fixed. It's not negotiating with DTP, and it's told you are a trunk port, and it's using encapsulation type .1q. So there are two configuration standards there. I don't know really why. That's quite strange. So let's look again on ALS1 and see what that running configuration looks like. So port channel 1, again DTP disabled, switching port mode trunk. Interestingly, there's no encapsulation, so the default must be 802.1q because it's negotiated, or it's not negotiated, but it's configured 802.1q. So I guess since we've configured ALS1 as new, we should probably get that to match the DLS1 because that's the only one that's changed. It's a tough question really because port channel 10 is configured physically with mode trunk and no negotiate, whereas port channel 1 is not configured like that. Look, I think the point I'm trying to make is if you've given this scenario and you're told that ALS1 is the only thing that's changed, then you shouldn't be changing configuration in the DLS link side of the link to make that work again. So we'll go ahead and try and bring ALS1 up without touching any configuration in DLS1, and probably the same in DLS2. So let's go in here, let's go into port channel 1, and we want this to negotiate, so we're going to do no switch port, no negotiate. That's the negative. This should spin up DTP. So the trunk should then come online. I'm just trying to think anything I've missed there. Although it is configured as a trunk. So we can probably get rid of that as well. So no switch port, mode trunk. But we do need one side to let's see. Show in trunk. Port channel 2 is trunking. port channel 1 is not. So that didn't work. Well, let's go into port 1, switch port mode trunk. Show into trunk. Whoops. I'm wondering if it may be running ISL or something. Without the encapsulation, the default might be ISL, and that's why it's not working. Let's go into port channel 1, switch port trunk, encapsulation. There's not even any. There's not even any configuration for that. So I guess we'll have to just configure DLS one side. Let's put it back. Switch port no negotiate. Let's do switch port mode trunk, and then on DLS 1 we'll go into port channel 1. We'll do switch port no negotiate and switch port. Oops. So it's currently in dynamic, which is what we thought was going to work. All right, and let's do switch port trunk encapsulation .1q, switch port mode trunk, and switch port no negotiate. That's on port channel 1. So now let's have a look. Showing trunk. So now it's trunking. Let's do the same for port channel 2. Let's just check the configuration on this one. And it's the same. So there's no encapsulation type, so let's assume ISL and it's trying to be negotiated there with the DTP. We're going to go in. We're going to port channel 2, switch port trunk encapsulation .1q, switch port mode trunk, and switch port no negotiate. Alright, show interface trunk. Oops, it's not forwarding any VLANs yet. Although that may be spanning tree, show spanning tree, VLAN 10. If it was spanning tree, I'd see that port alive and blocking. Let me just do showing trunk. It's definitely up. I wonder if ALS1 has got a problem. Let's just do showing trunk on this one. Okay, no do. Thank you, packet tracer. Show interface trunk. Now port channel 1's not forwarding for some reason. So this is very strange. DLS2 is not forwarding any VLANs. ALS1 is forwarding VLANs over port channel 2. But DLS2 is not allowing this. So yeah, that's weird. And this one. So DLS1 is allowing 10, 20, 30, 100 to go across port channel 1. Port channel 1 in return is allowing no VLANs. Port channel 2 is allowing 10, 20, and 30 to go through, but port channel 2 is not allowing any to return. So I assume spanning tree is broken because this is Let's check the so I'm allowing 10, 20, 30, 100, and all these are allowed. There's actually permitted capacities. And normally what you see, a block port, a block port. We don't see any of that. For example, shows 100 and 50. Yeah, so 10, 20, 30, 100 allowed, 100, one is like blocking ports, that's really strange. Shows the mode, RCD mode, shows spanning tree, summary. So my mode is PST, not rapid building spanning tree, maybe a factor, spanning tree mode, rapid PST. They are capital, so I'm hoping to show if I this. Show this trunk. So 4 no VLANs. Shut. Port channel 2, no shut. Alright, let's see now. Okay, that's more like it. That's better. Alright, so I guess, I don't know, must have been some kind of crazy inconsistency or software bug. I don't know. That was very strange. No configuration was changed in the last 5 minutes or so, so that was a strange one. Shut no shut saves the day. Alright, we've got VLAN 10 and 20, 10 and 30 forwarding over port channel 1, VLAN 20 forwarding over port channel 2. So hopefully now, let's try and do a release renew on this DHCP. If we have layer 2 reachability to DLS1, which we do. Alright, great. So PCB is now able to get a DHCP address lease from DLS 1. Let's just show that DHCP bindings on DLS1 10.1.10.1, which is the MAC address ending 8 alpha 92. Let's take a look if we can get that information from here. No, not ALS1, idiot. PCB, from PCB. My MAC address is ending 8A92, so 8A92 matches there. So that's good. What was the other part? Oh, so now we have to see if we've got reachability from PCB to the internet. So let's go to a command prompt and ping this internet IP address, which we can, and then we can't. Huh. Okay, and then we can, and then we can. Let's just try that again. Okay, must have been again a software issue. Let me just go back to this question. Your task is to diagnose the issue, allow host ALS1 to connect to the internet via DLS1 or DLS2. Right, so we need to make sure that PCB can use either a transit through DLS1, which goes through R1 to R2, or through DLS2, which goes through R3 to R2. In fact, even if we lost port channel 1, we could go at layer 3, ALS1, DLS2, DLS1, R1, and so on. If we lost port channel 2, we could go ALS1, well, at layer 3, PCB, DLS1, DLS2, 3, and 2. So there is a redundant topology, and they're just asking us basically to pull one of these switches and see if everything still works. So let's go, can we do a trace? Is there a trace ping? Huh. Trace route. Okay, so trace RT 10.1 202.1. All right, so at the moment we're going through 10.1.10.252, which is DLS2. Show IP in brief. 10.1.10.252, which is DLS1. Then we go 10.1.2.2, which should be R1. 10.1.2. Where's my local interface? It shows the subnet, so there we go, 10.1.2.2. All right, 10.1.2.2, and then 10.1.202.1 is on R2, so that's great. So we're going through DLS1. That's fine. All right. And that's because probably DLS1 only has one route to 10.1.202.1. So he has one best route using EtherChannel via 10.1.2.2. So that's fine. All right, we're just going to save that because I'm probably going to power this down. On DLS1, let's pull the power supply so it fails over. Well, so it fails. And then DLS2 should take over because DLS2's got some HSRP configured. Show standby brief. So this shows the status of HSRP, and you can see EtherChannel just failed there. So HSRP now, all of the VLANs are active on DLS2. So DLS2 has taken over the virtual IP address 10.1.10.254, which should be the gateway for this guy. I didn't check that. That's good. So it's getting the right gateway. 10.1.10.254 is the HSRP address shared between DLS1 and DLS2. So now DLS2 has that. Let's now try another trace route. And now we're going through 10.1.10.253, which is the physical address of DLS2. Show IP interface brief. 10.1.10.253. And then we go through 2.14, which should be R3. 2.14, and then straight on to R2. So that's proved that out. Let's power DLS1 back on. And DLS1 being the HSRP master should claim back the HSRP address for VLAN 10, which it has. So now it says that the active is 10.1.10.252, And the virtual IP address obviously stays the same. That's finished. So let's run another trace route. And now we're going through 252, which is DLS1, and then back through the same path. So I think that's everything. Look into the problem, determine blah blah blah, diagnose, allow hosts on ALS1 to connect to the internet, verify the switching environment is redundant. Okay, well we pulled the switch on DLS1. I suppose we should pull the switch on DLS2 just to make sure that that's, I mean the traffic isn't going that way anyway for VLAN 10, but we should try it anyway just to be complete. Let's pull the power out on DLS2. And this should make no difference to this whatsoever, because the traffic was going through DLS1 anyway, DLS1, R1, R2. But regarding R2, having two paths, it should only now have one path through R1, which it does. Okay, I think that's everything. Power this back up, save the topology, and just test it one more time, and then we'll be good. This could be purely related to packet tracer. I have seen this a bunch of times, and it always does this. So okay, packet tracer is clearly just having a laugh with me right now. So I think we're good. I think we're good. We checked all it. Which look, I've shut those interfaces and it's still online. That's crazy. Let's call it a day. I think we're fine. The configuration seems fine. The pings and trace routes are all working fine apart from now. So I'm going to put this down to a software issue and call it a day on the troubleshooting. It's all good. Okay. Best of luck, everybody. Bye now.